Hello, my name is Peter Miller,
My name is David Kempf.
and this is Feel the Noise. This is a piece of wearable hardware that converts sounds into tactile feedback. The use case for this is if you have a user who's deaf or hard of hearing, they can feel noises that are outside of the range of vision. So one example of this might be that you're walking down the sidewalk and someone comes up behind you on a bicycle and they ring their bell. Well, this jacket would vibrate so that you'd feel that something's happening that you should maybe turn around and look at.
We're able to make this happen by taking microphones and feeding the 3 microphones into a Raspberry Pi microcomputer. The Raspberry Pi is able to process the audio, send it over a serial connection to an Arduino microcontroller. The Arduino is then able to vibrate 3 vibrator motors located in the collar and interact with the user with some buttons. The motors in the collar are corresponding with each microphone, and we can demonstrate how that can give you a sense of directionality as wearing it. As I scratch the left microphone, you'll see the green LED light up. We've added LEDs to help the video experience. Now the center, and now the right.
All right. There are 2 buttons up here on the collar, and that allows the Arduino to send messages back to the Raspberry Pi to change the mode that this is functioning in. So as you press this button, it's going to shift modes, and we're already in mode 4, and we're going to demonstrate what that mode does. One of the advantages of using a Raspberry Pi is a little more processing power that we can use to filter the audio using fast Fourier transformations. So what this is going to do is cut out audio signals that are above 1,200 hertz.
This is an 800 hertz tone. And this is a 1600 hertz tone. The threshold for LEDs to light up is lower than the threshold for the vibrator motors to vibrate. So you would see a little bit of flickering, but you can see it's definitely different in the level of how much voltage is getting applied by the Arduino. We have a volume knob as well that the user can use to turn down the vibrations if they would like to ignore them. And the whole project is on battery power here. The Arduino running on the 9-volt and the Raspberry Pi running on a battery pack. So you can walk wherever you'd like to go. Thank you.
This is one of the other advantages of using Arduinos is